This one is packed. Generalist AI just dropped Gen-0, the first robot model that learns through real physical experience and scales past human reflexes. Unitree's latest humanoids are going viral again with lifelike dance demos. Galbot's Any2Track is pushing motion tracking to new extremes. 1X's Neo is literally baking alongside chef Amaury Guichon. China just dropped AI-powered robot dinosaurs. And XPENG started mass-producing flying cars. It's getting hard to keep up, so let's break it down. So Gen-0, this isn't just another robot model, it's what Generalist AI calls an embodied foundation model, trained directly on real-world interaction instead of text or simulation. It learns by seeing, touching, and moving, with over 270,000 hours of robot experience from homes, warehouses, and factories, and 10,000 new hours added every week, the biggest robotics dataset ever made. Its core idea, called harmonic reasoning, lets the robot think and act at the same time. Unlike chatbots that can pause to think, Gen-0 keeps processing sensory input and motion together, leading to smooth, natural behavior without rigid steps. It's been tested on everything from robotic arms to humanoids and adapts across all of them. In one demo, it built a full camera kit, folding boxes, unpacking, organizing, and cleaning up, all in a single continuous flow. What makes Gen-0 groundbreaking is how it scales. Smaller models with about 1 billion parameters hit a wall and stop learning, but once the model passes 7 billion, it starts improving rapidly, what researchers call the intelligence threshold. From there, more data and compute lead to steady, predictable gains, just like in large language models. To support that, Generalist AI built a massive global system with dedicated internet lines, multi-cloud storage, and 10,000 processing cores, capable of processing nearly 7 years of real-world experience every single day. They also created a universe of manipulation, a searchable map of millions of human-like tasks, such as folding laundry or tightening bolts. Their research shows quality and diversity matter more than raw data size. Mixing experience from homes, factories, and labs makes models more flexible and precise. Gen-0 proves that robots can now scale real-world intelligence the same way AI models scaled language, by learning from experience, not code. Now, while Gen-0 is showing what the future of embodied AI looks like, on the more public side, we're seeing how fast companies like Unitree, Figure, and 1X are competing for attention, and sometimes even entertainment. Unitree's robots have been going viral again, especially their G1 humanoid doing synchronized K-pop dances. The flexibility of its joints and balance control is undeniably impressive, but people online are pointing out the limitations too. One user joked that it can dance, but can't carry a heavy box. Another said the hardware might degrade fast, and someone even called it a toy. There's also this recurring comment about how impressive it looks visually, but still lacks grip precision and coordination for real tasks. In fact, when Cody Detweiler, the YouTuber, tried one of these robots, it was intentionally trained for abuse, which made its chaotic behavior sort of expected. But when Chinese engineer Zheng Yuan tried controlling one, it showed real limitations in fine motor control. The truth is, Unitree's G1 is mechanically agile, but still lags behind competitors like Tesla's Optimus or Figure 03 in actual practical intelligence. Those other robots are starting to do meaningful, structured tasks, cooking, cleaning, and basic assembly, without falling apart mid-demo. It's kind of funny watching these mishaps online, but they're a reminder that coordination, not movement, is the real challenge. And speaking of motion control, another clip that blew up online was from Galbot's Any2Track system. It's basically a whole-body motion tracking system that uses a two-stage reinforcement learning framework. It learns from human motion capture data and adds dynamics-aware prediction so it can stay stable under disturbances. People on X joked about it. One guy said, "Nice, but can it change diapers in nursing homes?" While another said, "We'll have 1 million dancing robots, none that can climb a ladder." It's funny, but the tech itself is serious. The system can track contact-rich human motions like kung fu moves or gymnastics, and it's learning to adapt to unexpected shifts in balance. It's that exact kind of tech that'll eventually feed into humanoids doing real physical labor or entertainment. Then there's the softer side of robotics, literally. The humanoid company 1X, best known for its Neo robot, just teamed up with the world-famous pastry chef Amaury Guichon. They worked together on a dessert shaped like a 1X tech shipping box, complete with edible foam peanuts and metal tools made of chocolate. The video shows Neo acting as Guichon's assistant in the kitchen, handling utensils and working side by side. It's playful, but actually demonstrates the robot's tendon-driven hands and safe design for close human collaboration. What's even more interesting is that Guichon isn't just doing this as a marketing stunt. He's actually one of 1X's earliest customers, which reframes the whole collaboration as a genuine, real-world test. 1X's VP of product even said they only collaborate with creators who truly love the robot. Of course, there's been controversy around Neo's expert mode, where a human teleoperator controls it remotely to generate data. Critics like Marquise Brownlee have called it selling the dream, but 1X insists that human in-the-loop control is the necessary first step toward real autonomy. The Guichon collab fits that philosophy perfectly. It's safe, controlled, but still dynamic enough to showcase what the robot can do in a human environment. Meanwhile, China is going full speed in another direction entirely: robot dinosaurs. Yeah, that's real. Two Chinese companies, LimX Dynamics and Yuejiang Technology, also known as Dobot, just launched AI-powered robotic dinosaur platforms. Dobot's version is called the Sinosauroptics, a feathered bipedal bot equipped with optical sensors and pre-programmed motion controls. It walks on two legs, stalks around museums, and even wears a feathery skin that can be swapped out for different dino types. Their viral video on Douyin shows it roaming through a museum at night, and it honestly looks straight out of Jurassic Park. LimX, on the other hand, showed off their Tron 1 bot dressed as a T-Rex for Halloween. It's not a dedicated dinosaur robot, but it's bipedal and capable of stabilizing itself after being pushed or bullied by handlers. The clip went viral across Chinese social media. Both robots are part of China's booming consumer robotics scene, a shift from purely industrial machines to entertainment and education. And considering how fast China's been building things lately, it's probably only a matter of time before there's a full robotic Jurassic Park somewhere off the coast. But the craziest story this week might actually come from XPENG Aero HT, the flying car division of XPENG. They just started trial production at what's now officially the world's first intelligent factory for mass-produced flying cars. It's in Guangzhou and spans over 120,000 square meters. The model they're building is called the Land Aircraft Carrier, and it's a modular flying car that combines a six-wheel ground vehicle with a detachable electric aircraft module. The flying part uses electric vertical takeoff and landing tech and supports both manual and automatic flight modes. In automatic mode, it can plan its route, take off, and land with a single tap. The whole vehicle is about 5.5 meters long, small enough to park in a normal space, and can be driven on public roads with a standard license. The factory can produce 5,000 units per year right now and will eventually scale to 10,000. XPENG says it already has close to 5,000 orders, with deliveries starting in 2026. Once the factory hits full speed, they'll be able to assemble one aircraft every 30 minutes. That's an aircraft rolling off the line twice an hour. It's the first real step toward commercialized flying cars built at the same scale we build normal electric vehicles today. That's all for today. Thanks for watching, and catch you in the next one.